Hi guys, tonight we're diving into one of the most catastrophic scenarios our planet could face. What would happen if Earth suddenly stopped spinning? We're talking about a world where half the planet is locked in eternal daylight, while the other half remains in perpetual darkness forever. If you enjoy these intense sleep stories that explore planetary scale disasters, hit that like button and subscribe for more. And drop a comment letting me know what time it is where you are and where you're listening from. I love connecting with listeners across every time zone. Alright, let's begin. The morning alarm clock rings at 6:30 as usual in Tokyo, but something is fundamentally wrong. The sun, which should be climbing steadily toward its midday zenith, has frozen in place roughly 20 degrees above the eastern horizon. In New York City, where it should be early evening the day before due to time zones, darkness has settled permanently over Manhattan's skyline. Across the globe, half the planet basks in eternal daylight, while the other half remains locked in perpetual night. Earth has stopped spinning. This scenario, while seemingly impossible, represents one of the most catastrophic events that could befall our planet. To understand the full magnitude of what would happen if Earth suddenly ceased its rotation, we must first grasp the tremendous forces at play. Our planet spins on its axis at approximately 1,040 miles per hour at the equator, completing one full rotation every 23 hours, 56 minutes, and 4 seconds. This rotation has continued uninterrupted for over 4.5 billion years, creating the day-night cycle that governs virtually every aspect of life on Earth. The moment Earth stops spinning, the laws of physics would unleash forces beyond human comprehension. Every object on the planet's surface, including the atmosphere, oceans, buildings, and all 7.8 billion humans, would continue moving eastward at their current rotational velocity due to inertia. At the equator, this means everything would suddenly be travelling at over 1,000 miles per hour, relative to the now stationary ground beneath. The immediate aftermath would be nothing short of apocalyptic. In cities like Quito, Ecuador, which sits almost directly on the equator, buildings would be ripped from their foundations and hurled eastward like projectiles fired from an impossibly massive cannon. The force would be equivalent to a magnitude 15 earthquake, far beyond anything ever recorded in human history. The most powerful earthquake ever measured, the Great Chilean Earthquake of 1960, registered magnitude 9.5 and caused devastating tsunamis across the Pacific. What we're describing would be orders of magnitude more destructive. Moving away from the equator, the effects would gradually diminish but remain catastrophic. At 45 degrees north latitude, where cities like Minneapolis, Milan and Vladivostok are located, objects would still be moving at approximately 730 miles per hour. Even at 60 degrees north, encompassing cities like Helsinki, Anchorage and the southern tip of Greenland, the velocity would still reach 120 miles per hour. Only at the poles would the rotational velocity be essentially zero, making these the only potentially survivable locations on the planet's surface. The atmosphere itself would become a weapon of unimaginable destruction. The entire gaseous envelope surrounding our planet, from the troposphere extending up to 18 kilometers at the equator to the stratosphere reaching 50 kilometers in altitude, would continue its eastward motion. This would create supersonic winds exceeding 3 times the speed of sound, turning the air into a devastating force capable of scouring the landscape clean. These winds would carry with them billions of tons of debris, creating a global sandstorm of pulverized concrete, twisted metal, and organic matter. But the atmospheric chaos would extend far beyond mere wind speed. The sudden cessation of Earth's rotation would disrupt the Coriolis effect, the force responsible for global weather patterns, ocean currents, and atmospheric circulation. Without this force, the trade winds that have carried moisture and regulated temperature across continents for millions of years would collapse. The jet streams, those high-altitude rivers of air that circle the globe at speeds reaching up to 400 kilometers per hour, would destabilize and dissipate. The immediate temperature extremes would be staggering. The side of Earth facing the sun would begin experiencing unprecedented heating, while the dark side would start cooling rapidly. Without the moderating effect of day-night cycling, the sunny side would eventually reach temperatures exceeding 60 degrees Celsius in many regions, hot enough to kill most plant and animal life. Meanwhile, the dark side would plunge toward temperatures of minus 100 degrees Celsius or lower, creating a frozen wasteland where even the atmosphere might begin to condense and fall as snow. The world's oceans, containing approximately 1.4 billion cubic kilometers of water, would face their own catastrophic transformation. The sudden stopping of Earth's rotation would create massive tsunamis as the ocean waters continued their eastward motion, while the sea floor beneath them came to a halt. These tsunamis would dwarf any in recorded history, with waves potentially reaching heights of several kilometers as they crashed into continental landmasses. Consider the Pacific Ocean, the largest body of water on Earth, covering 165 million square kilometers. The sheer momentum of this water mass, moving at varying speeds depending on latitude, would create a complex pattern of devastating waves. Near the equator, these waves would travel at speeds approaching 1,000 miles per hour, carrying the energy equivalent of millions of nuclear weapons. As they approach shallower coastal waters, they would grow in height while maintaining their tremendous energy, potentially submerging entire coastal mountain ranges. The Atlantic Ocean, with its volume of approximately 310 million cubic kilometers, would experience similar chaos. The eastern seaboard of the United States, from Florida to Maine, would face tsunamis of unprecedented scale. Cities like Miami, with its elevation barely 2 meters above sea level, would vanish entirely beneath walls of water stretching dozens of kilometers inland. New York Harbor, which handles cargo worth over $200 billion annually, would be obliterated along with the surrounding metropolitan area housing 20 million people. But perhaps most critically affected would be the global ocean circulation system, often called the global conveyor belt. This system moves approximately 150 times the flow of the Amazon River around the globe, distributing heat from the equator toward the poles and maintaining the relatively stable climate that has allowed human civilization to flourish. The Gulf Stream alone carries approximately 30 million cubic meters of water per second northward along the eastern coast of North America, bringing with it roughly 1.4 petawatts of heat energy, equivalent to the output of 1 million nuclear power plants. When Earth's rotation stops, this entire system would collapse catastrophically. The thermohaline circulation, driven by differences in water temperature and salinity, would be overwhelmed by the mechanical disruption. The warm waters that currently keep Western Europe habitable, despite its northern latitude, would stop flowing. London, at roughly the same latitude as Labrador, would lose the warming influence that maintains its relatively mild climate. Without the Gulf Stream, temperatures in the British Isles would plummet by an average of 5 to 10 degrees Celsius, even on the sunlit side of the stopped Earth. The disruption would extend to the deep ocean currents that circulate nutrients and oxygen throughout the marine environment. These currents, which can take over 1,000 years to complete a full cycle, support marine ecosystems that produce approximately 50% of the world's oxygen and absorb roughly 25% of human-generated carbon dioxide. The collapse of these systems would trigger a cascade of ecological disasters that would make the surface devastation seem modest by comparison. Marine life would face extinction on an unprecedented scale. The world's fisheries, which currently provide protein for over 3 billion people and represent an industry worth approximately $150 billion annually, would collapse entirely. The disruption of ocean currents would eliminate the upwelling of nutrient-rich deep waters that support phytoplankton populations. These microscopic organisms, despite their tiny size, represent the foundation of oceanic food webs and produce more oxygen than all terrestrial plants combined. Coral reefs, already stressed by climate change and representing ecosystems that support 25% of all marine species, despite covering less than 1% of ocean area, would face complete annihilation. The Great Barrier Reef, stretching over 2,300 kilometers and visible from space, supports an ecosystem worth approximately $6 billion, $0.4 billion annually to Australia's economy. The thermal shock from disrupted ocean circulation, combined with the mechanical devastation of massive tsunamis, would destroy these fragile ecosystems within days. On land, the ecological catastrophe would be equally severe, but manifest differently on each side of the divided planet. The sunny side would face extreme desertification as temperatures soared and atmospheric circulation patterns collapsed. Forests that currently store approximately 850 billion tons of carbon would face mass die-offs. The Amazon rainforest, covering approximately 5.5 million square kilometers and containing an estimated 10% of known biodiversity, would transform from a carbon sink into a massive carbon source as vegetation died and decomposed or burned in the extreme heat. The boreal forests of Canada, Russia, and Scandinavia, covering approximately 17 million square kilometers and storing roughly twice as much carbon as tropical forests, would face their own destruction. On the sunny side, they would desiccate and burn in unprecedented wildfires. On the dark side, they would freeze and die as temperatures plummeted far below the survival threshold of even the most cold-adapted species. Agricultural systems would collapse globally within days. The world currently produces approximately 2.7 billion tons of cereal grains annually, feeding the majority of humanity either directly or through livestock. The major grain-producing regions, from the American Midwest to the Ukrainian steppes to the North China Plain, would become uninhabitable. The United States alone produces approximately 400 million tons of corn annually, much of it in Iowa, Illinois, and Nebraska, states that would face either extreme heating or freezing depending on their longitude when the rotation stopped. The human toll would be beyond calculation. Major population centers would face complete destruction within hours. Tokyo, home to 37 million people in its greater metropolitan area, would experience devastating forces as it sits at approximately 35 degrees north latitude, meaning objects would continue moving eastward at roughly 800 miles per hour. The city's infrastructure, from its world-renowned train system carrying 40 million passengers daily to its port-handling container traffic, worth over $700 billion annually, would be obliterated instantly. Mumbai, India's financial capital and home to over 20 million people, sits at approximately 19 degrees north latitude, meaning it would experience rotational velocities of nearly 950 miles per hour. The city's massive slums, where millions live in structures not designed to withstand even moderate earthquakes, would simply vanish. The economic impact would be staggering, as Mumbai accounts for approximately 10% of India's GDP and handles roughly 40% of the country's foreign trade through its ports. São Paulo, Brazil's largest city with over 12 million inhabitants, sits at 23 degrees south latitude, placing it in a zone of extreme devastation, with rotational velocities approaching 900 miles per hour. As the economic heart of South America's largest economy, accounting for approximately 12% of Brazil's GDP, its destruction would trigger continental economic collapse. But beyond the immediate physical destruction, the stopped Earth would face a crisis of resource distribution that would make survival virtually impossible for any remaining human populations. The global supply chain, a complex network that moves approximately 11 billion tons of goods annually worth over $14 trillion, would cease to exist. Modern agriculture depends on inputs transported from around the world. Fertilizers produced primarily in Russia, China, and Canada. Seeds developed through international breeding programs. Machinery manufactured across multiple continents. And fuel extracted and refined in dozens of countries. The electrical grid, humanity's nervous system carrying approximately 28,000 terawatt-hours of energy annually, would fail catastrophically. Power plants designed to operate within specific temperature ranges would shut down as some overheated and others froze. The loss of cooling water from destroyed rivers and coastal facilities would force nuclear plants into emergency shutdowns, though many would likely face meltdowns as backup systems failed and maintenance became impossible. The failure of electrical systems would cascade through every aspect of modern civilization. Water treatment facilities serving billions of people would stop operating. The global internet carrying data worth trillions of dollars and connecting over 5 billion users would go dark as server farms lost power and cooling. Financial markets, processing transactions worth over $5 trillion daily, would freeze permanently. The just-in-time delivery systems that keep supermarkets stocked and hospitals supplied would collapse, leaving surviving populations without access to food, medicine, or basic necessities. Transportation networks worth hundreds of billions of dollars would be destroyed instantly. The world's airports, which handle over 4 billion passengers and 58 million tons of freight annually, would see aircraft hurled across runways like toys. Ships at sea would face tsunamis and extreme weather that would sink even the largest vessels. The global shipping fleet carrying approximately 90% of international trade would be reduced to scattered debris floating in chaotic oceans. The psychological impact on any survivors would be profound and lasting. Humans have evolved with the rhythm of day and night cycles, and our circadian biology is intimately connected to the Earth's rotation. On the sunny side of the stopped planet, populations would face the stress of endless daylight, disrupting sleep patterns and causing widespread psychological disorders. The constant heat and light would create conditions resembling extreme sensory torture, driving people to seek shelter in increasingly desperate circumstances. On the dark side, the situation would be equally devastating but different in character. Perpetual darkness would trigger widespread depression and vitamin D deficiency, weakening immune systems and making survivors more susceptible to disease. The extreme cold would force people into smaller and smaller refuges, concentrating populations in ways that would accelerate the spread of infectious diseases. Without modern medical facilities and pharmaceutical supplies, even common infections would become deadly. The long-term implications extend far beyond immediate survival. Earth's magnetic field, generated by the motion of molten iron in the planet's outer core, depends partly on the planet's rotation through the dynamo effect. While the core would continue spinning initially due to its own momentum, the sudden cessation of surface rotation would disrupt the complex interactions that maintain our magnetic field. This field currently deflects approximately 99% of harmful cosmic radiation and solar wind particles that would otherwise strip away our atmosphere and irradiate the surface. Without adequate magnetic field protection, the atmosphere itself would begin a slow process of erosion similar to what occurred on Mars billions of years ago. Solar wind particles, travelling at speeds of approximately 400 kilometers per second, would gradually strip away atmospheric gases, particularly the lighter elements like hydrogen and helium. This process would take thousands of years but it would eventually leave Earth as a barren, airless world incapable of supporting any form of life as we know it. The geological consequences would unfold over longer timescales, but with equally devastating results. Earth's rotation creates a centrifugal force that causes our planet to bulge at the equator by approximately 21 kilometers compared to the polar diameter. When rotation stops, this bulge would gradually settle, causing the oceans to redistribute toward the poles and exposing vast areas of currently submerged equatorial ocean floor while flooding polar regions. This redistribution would create entirely new continental configurations over geological time. The Mariana Trench, currently the deepest part of the world's oceans at nearly 11 kilometers below sea level, might find itself partially exposed as water flows poleward. Meanwhile, areas like northern Canada, Greenland and Antarctica would disappear beneath kilometers of water as the planet's shape slowly adjusted to its new, non-rotating state. Tidal forces from the moon and sun would take on entirely new significance in this stopped world. Currently, Earth's rapid rotation means that tidal bulges move around the planet relatively quickly, creating the familiar twice-daily high and low tides. With rotation stopped, these bulges would become fixed features, creating permanent high tide zones beneath the moon and on the opposite side of the planet, while other areas would experience permanent low tide. The moon itself would eventually slow in its orbit due to the changed tidal dynamics, gradually spiraling inward toward Earth over millions of years. This would increase tidal forces exponentially, potentially creating tidal ranges of hundreds of meters that would inundate vast areas of land twice per month as the moon orbited the now stationary Earth. Climate patterns on the divided planet would evolve into something completely alien to terrestrial life. The sunny side would develop massive convection cells as superheated air rose from the surface and cooled in the upper atmosphere before descending again. These would create powerful stationary storm systems, unlike anything in Earth's current meteorology. The temperature differential between the heated surface and the cold upper atmosphere would drive winds that could reach velocities exceeding those of Category 5 hurricanes. But these would be permanent fixtures rather than transient weather events. The boundary zone between the light and dark sides, often called the terminator line, would become a region of extreme weather instability. The stark temperature difference between the two sides would create permanent storm systems along this boundary, with temperature gradients that could exceed 50 degrees Celsius within a few dozen kilometers. These storm systems would generate lightning on a scale never before seen on Earth, potentially creating electromagnetic disturbances that would affect any surviving electronic equipment for thousands of kilometers in all directions. On the dark side, the lack of solar heating would eventually cause atmospheric gases to condense and fall as snow. Water vapor would freeze out first, creating vast snowfields of ice crystals. As temperatures continued to drop, even nitrogen and oxygen might begin to liquefy and freeze, creating a landscape of frozen air accumulating in low-lying areas. The atmospheric pressure would gradually decrease as gases condensed, creating conditions similar to being at extreme altitude where human survival would be impossible without pressurized shelter. The biological implications of this scenario extend far beyond immediate extinction. The evolutionary adaptations that have shaped life on Earth for billions of years are all based on the assumption of regular day-night cycles, seasonal variations, and the complex climate patterns created by planetary rotation. Every organism, from the smallest bacteria to the largest mammals, has evolved circadian rhythms and metabolic processes synchronized with Earth's 24-hour rotation. Plants, which form the foundation of virtually all terrestrial food webs, would face complete extinction. Photosynthesis requires not only sunlight, but also specific temperature ranges and atmospheric conditions. On the sunny side, temperatures would quickly exceed the thermal tolerance of even the most heat-adapted plants, while the lack of atmospheric circulation would eliminate the carbon dioxide convection necessary for efficient photosynthesis. On the dark side, the absence of light would halt photosynthesis entirely, causing all plant life to exhaust its stored energy reserves within days or weeks. The collapse of plant life would trigger a cascade of extinctions throughout all terrestrial ecosystems. Herbivores would face starvation within weeks as their food sources disappeared. Carnivores would follow shortly after as their prey species died off. Decomposer organisms like bacteria and fungi, which break down organic matter and recycle nutrients, would face extreme temperature conditions that would halt their metabolic processes, leading to the accumulation of organic debris that would never be recycled back into the ecosystem. Marine ecosystems would fare no better. The disruption of ocean circulation would eliminate the nutrient cycling that supports marine food webs. Phytoplankton, the microscopic plants that form the base of oceanic food chains, require specific temperature ranges and nutrient concentrations that would be impossible to maintain in the chaotic post-rotation environment. Their collapse would eliminate the food source for zooplankton, which in turn support fish populations, marine mammals, and seabirds. The acidification of the oceans would accelerate without the normal circulation patterns that help buffer pH changes. As atmospheric carbon dioxide levels fluctuated wildly due to the collapse of terrestrial vegetation and the disruption of normal chemical cycles, the oceans would absorb these changes, creating conditions that would dissolve the shells and skeletons of marine organisms like corals, mollusks, and many types of plankton. Yet perhaps the most haunting aspect of this scenario is not the scale of immediate destruction, but the complete severance of the connection between Earth and the cosmic rhythms that have governed life for billions of years. The alternation of day and night, the changing of seasons, the rise and fall of tides, all of these fundamental patterns that have shaped the evolution of life would cease to exist. Any hypothetical survivors would face not just physical challenges, but the psychological trauma of living in a world where the most basic assumptions about existence no longer applied. The stopped Earth would become a monument to the delicate balance that allows life to flourish in the cosmos. Every aspect of our planet's habitability, from the protective magnetic field to the stable climate patterns to the complex biogeochemical cycles that maintain atmospheric composition, depends on the continued rotation that we take so completely for granted. The cessation of this rotation would reveal just how precisely tuned our planetary system must be to support the incredible diversity of life that calls Earth home. In contemplating this scenario, we gain a deeper appreciation for the remarkable stability of the astronomical and geological processes that have allowed human civilization to develop over the past 10,000 years. The fact that Earth has maintained its rotational stability for over 4 billion years, through countless asteroid impacts, volcanic cataclysms, and climate changes, represents one of the most fundamental requirements for our existence. Understanding what would happen if this stability were lost helps illuminate not just the fragility of our world, but the incredible interconnectedness of all the systems that make life possible on the third planet from the Sun. The stopped Earth scenario ultimately serves as a reminder that we inhabit a dynamic, interconnected system where every component, from the smallest atmospheric circulation cell to the largest ocean current, plays a crucial role in maintaining the conditions that allow life to thrive. In recognizing these connections, we can better appreciate both the resilience and the vulnerability of the remarkable planet we call home.